There is a very strange object flying past our sun. We don't exactly know what this thing is, but we've been watching it for months. We've given it a name, 3I Atlas, and a title, Interstellar Comet. The 3I signifies it's the third confirmed interstellar object, a visitor from beyond our own solar system. The Atlas honors the telescope system that found it. Right now, 3I Atlas is making its closest approach to the sun, a phase astronomers call perihelion. It will pass within about 1.4 astronomical units of our star. An astronomical unit, or AU, is the distance from the Earth to the Sun, about 150 million kilometers. So, this object is passing just inside the orbit of Mars, getting a close-up look at our inner solar system. This is the hottest it will get on its journey, a crucial moment for scientists. The intense solar radiation is causing volatile materials from its surface to blast into space. This process, called sublimation, is what gives a comet its distinct fuzzy halo, or coma, and a long dramatic tail. It's our best chance to analyze the ancient material it's made of. Unfortunately, our view of this peak activity is completely blocked by the glare of the sun. It's a frustrating cosmic alignment. The most interesting part of its visit is happening behind a curtain of light, so while we wait for it to reappear on the other side, let's investigate the incredible journey that brought it here. We've been tracking 3I Atlas since July 2025. It was spotted by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a network of robotic telescopes that scan the entire night sky every 24 hours searching for moving objects like asteroids and comets that could pose a threat to Earth. But their automated systems noticed something weird about this one. It was moving far too fast. Everything in our solar system, from the smallest asteroid to the largest planet, is gravitationally bound to the sun, trapped in elliptical orbits. But if an object moves fast enough, exceeding what we call escape velocity, it can break free from the sun's gravity and fly off into interstellar space. When astronomers clocked this new object, they were shocked. At 58 kilometers per second, while still out near the orbit of Jupiter, it was the fastest moving object ever detected in our solar system. It wasn't just exceeding escape velocity, it was shattering the record. The math was undeniable. This object had a hyperbolic trajectory, a clear, open-ended path. It came from the void between stars, and that's exactly where it was going to return. It was just passing through. This is only the third interstellar object we've ever identified. The first was the famous Oumuamua in 2017, a bizarre cigar-shaped object that showed no cometary activity. The second was 2I Borisov in 2019, which acted much more like a normal comet, giving us our first real taste of chemistry from another star system. But 3I Atlas is different from its older siblings in three big ways. One is its sheer size. At an estimated diameter of up to 5.6 kilometers, it's a giant, dwarfing both the sub-kilometer Oumuamua and the roughly 1 kilometer Borisov. This makes it a much more substantial and potentially pristine sample of its home system. 2 is its incredible speed. Atlas travels at about double the velocity of Oumuamua and Borisov, a fact that hints at a more violent or energetic origin. And 3, perhaps the most puzzling aspect, is its direction. Oumuamua and Borisov came plunging in from high above and below the solar system, at steep, random angles. But 3I Atlas is a T-bone, coming in almost perfectly aligned with the flat disk where all the planets orbit, a region called the plane of the ecliptic. The object is only 3 degrees off from that plane. For something that could have come from any direction in the vastness of three-dimensional space, arriving on the same plane as our planets is a very, very big coincidence. It's like throwing a dart from across a stadium and having it land perfectly flat on the edge of a spinning record. So where did it come from? By tracing its path backward, we know it came from the direction of the galactic core. More specifically, astronomers believe it originated in what's called the thick disk of the Milky Way. This is an ancient, diffuse halo of stars that surrounds the brighter, flatter, thin disk where our own sun resides. Stars in the thick disk are older and their orbits are more chaotic. Things tend to hang out there, undisturbed, for very long periods. This origin story could make 3I Atlas as old as 7.6 billion years, nearly twice the age of our own planet, a true relic from the galaxy's adolescence. While we can't trace its full journey across the galaxy, astronomers have backtracked its path over 10 million years. In all that time, the closest it came to any other star was a distant 0.3 light-years away. It has been a lonely traveler for eons, and right now, after all that time in the cold, dark void, it's just 1.4 astronomical units from our sun. Our first glimpse of 3I Atlas actually came before its official discovery, hidden in plain sight. In May 2025, NASA's Transiting Exoplanet Survey Satellite, or TESS, happened to be looking in its direction. As the object traveled about 1 astronomical unit closer to the sun, its brightness was expected to increase by a factor of 1.5, simply due to it getting closer. Instead, archival data showed its brightness exploded, increasing by a factor of 5. This massive, unexpected increase in reflected light was the smoking gun. It confirmed 3I Atlas was a comet, actively forming its coma of gas and dust far earlier than anticipated. But there were two weird things about this early activity. First, the light it reflected showed the most extreme, negative polarization of any object ever discovered. Polarization tells us about the texture and composition of the dust particles reflecting the sunlight. This extreme reading suggests the material in its coma is very different from the dust in our own solar system, perhaps fluffier, more porous, or made of exotic grains we've never seen before. Second, the fact that the coma formed at all was a surprise. 3I Atlas was still way out beyond Jupiter, over 5 AU from the Sun. At that distance, it's typically far too cold for the water ice in most comets to sublimate. The reason? Its early coma was dominated by carbon dioxide gas, or CO2. Like the dry ice we use on Earth, frozen CO2 sublimates at much lower temperatures than water ice, allowing 3I Atlas to turn on much farther out from the Sun's warmth. As 3I Atlas got closer, we saw that ratio of CO2 and water begin to flip. It was like watching the comet shed its outer layers. By late September, as it passed the orbit of Mars, the object began releasing a massive amount of water vapor. More than we'd expect even from a normal, water-rich comet at this distance. It was as if the outer shell of dry ice had finally burned away, exposing a core incredibly rich in water ice. We saw a similar bizarre pattern with metals. At first, spectrographs detected nickel in the coma, but no iron. This is strange because the two metals are cosmic twins. They almost always appear together in asteroids and comets. Then, just as suddenly as the water appeared, iron showed up in the data, and the ratio of nickel to iron snapped into a normal, expected range. It seems 3I Atlas is becoming more normal over time, but it's getting there in a very strange, layered way. Even its tail was unusual at first. When it began forming far out in the solar system, it was pointing in the wrong direction, towards the sun. This anti-tail was likely an optical illusion combined with a real physical effect. The coma formed so far out that the solar wind, the stream of charged particles from the sun that pushes comet tails away, wasn't strong enough yet to push the larger, heavier dust particles. So, they were left trailing along the comet's orbit, and from our perspective, they appeared to point toward the sun. By September, as the comet flew deeper into the solar system, a normal fan-shaped tail of gas and dust, pushed by a stronger solar wind, had developed. On October 3rd, the object passed just 0.19 AU from Mars, giving us our closest look yet. This image from the Perseverance rover shows how it appeared as a bright streak in the Martian night sky. And this one, from the European Space Agency's ExoMars orbiter, gives a slightly clearer, though still unresolved, view of the bright, fuzzy coma. These were precious, fleeting observations from our robotic ambassadors on the Red Planet. Unfortunately, a planned, more detailed observation with the high-resolution camera on NASA's Mars Reconnaissance Orbiter was impacted by a US government shutdown, a frustrating reminder of how earthly problems can affect our exploration of the cosmos. For now, time is something we have. The sun will continue blocking our view until early December. 3I Atlas will be closest to Earth on December 19th, though still a very safe 1.4 AU away, and well on its way out of the solar system. Our telescopes will be waiting, ready to see how its intense solar passage has changed it. But there is one more close encounter to come. On March 16, 2026, the object will fly within 0.36 AU of Jupiter. We have one camera there, on a probe called Juno, which is currently studying the gas giant. It will have a chance to pivot and take one last long-distance image of 3I Atlas before it disappears back into the void forever. At that distance, the object will be cooling down rapidly, its activity fading, but it could be fundamentally changed by its brief, violent exposure to our sun. It's possible that many of its strange characteristics are just an accumulation of weird cosmic dust and radiation damage it picked up along its incredible billion-year journey. The sun may have sandblasted it clean, revealing its true nature underneath. For now we can only wonder, but more answers and probably more questions are soon to come.